Now let's look at how to turn a square into a cube. Freehand, you just create a square behind the first square. Each square has 4 vertices, and you connect the corresponding vertices to create a cube. A cube has 6 sides. 1, 2, 3, 4, 5, 6. The sides are each in the shape of a square. So all 6 sides are equal. The sides are also known as planes. A shape and a plane are synonymous. They both have 2 dimensions, height and width. A cube has depth. So a cube is a 3-dimensional object, whereas a shape is a 2-dimensional object. This shape, this plane, is on the edge of this cube. Okay, so this cube is made from 6 different planes put together. Where the planes each meet create an edge. Right? There are 12 edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 edges on a cube. Okay, so this is referred to as an edge. Okay. Where 3 planes meet at this point, this is called a vertex. Plural for vertex is vertices. There are 8 vertices on a cube. An exploded view of a cube where each plane is separated at its edges looks like this. This is useful because remember how we used a square and we found the center of the square and the center of each of the edges of the square to find the circle? Well, the same method applies to each of the planes of this exploded view. Well, we can use a cube to find and construct a sphere. So I'm going to use color pencils for this so that we don't get lost. So I'm going to find the center of each of the planes. So I have found the center of the 2 side planes, the top plane and the bottom plane. I'm going to mark off that center with red color pencil. And if I connect those points with a circle, that's step 1. Step 2, I'm going to find the center of the front and the back planes. So right now I'm finding the center of the front plane. I'm going to mark it with a different color. And now I'm going to find the center of the back plane. We already know the center of the 2 side planes. So now I'm going to connect those points with an ellipse. So the axis of rotation of your ellipse, remember, your ellipse has an axis of rotation major and an axis minor. This cross-section of the sphere is the horizontal cross-section. The vertical cross-section, we connect the points of the top and the front, the bottom and the back planes. And the axis of rotation of that green vertical cross-section is there. Inscribing a sphere, within a cube is a very similar process to inscribing a circle within a square. The same concept applies. You just have to keep track of the center points of each plane. You can also use a cube to find a cone with the same methodology. So I'm going to find the center of the bottom plane first, and the center of the top plane. I'm going to mark that with a green dot. I also want to find the center of the front plane, and I'm going to use the center of the front plane, the distance from the center to the edge of the front plane, to find the center of the bottom edge of the front plane and the top edge of the front plane. Find the center of the back plane. And I'm going to use the distance on the back plane from the center to the back edge to find the center of the back edge top and the back edge bottom. On the bottom plane, I'm going to connect the center of the bottom plane with the center of the front edge and the back edge. I'm not going to do the same thing on the top because ultimately we want a cone, and the tip of the cone is going to be in the center. What we're looking for is the base of the cone. So I'm going to find the center of both side planes. And I'm going to use the distance from the center to the edge to find the center of the side plane. So now I can connect the axis of rotation major of what will be the base of the cone. Okay. Remember, a circle in perspective is an ellipse. So now I can connect the tip, where the cone tip is going to go, with the center of the side plane. As you can see, you can use the same concept of finding the center of a plane on each side of a cube to construct a cone. Now we're going to make a cylinder with the same concept. I'm going to find the center of the front plane, use the distance from the center to the edge to find the edge, the center of the bottom edge. And I'll find the center of the back plane. So the center of the back plane and the center of the bottom of the front plane, I'm going to connect those. And I'll connect the center points at the top. What you're looking at this stage is a cross-section of the cube. The cross-section of a cube is going to be a square in perspective. So let's find the perpendicular cross-section. I'm going to find the center of the right plane and the center of the left plane. Connect those points. So now I can connect the bottom of the right side with the bottom of the left side. And the top of the right side with the top of the left side. So now you're looking at the cross section. I'm going to lighten up that back corner just a little bit. So now you're looking at a cube that is split in half both ways. Now remember, a cylinder is round. So here's an example. When you're looking at a cylinder straight on, you see a circle. In perspective, that circle becomes an ellipse. So we're going to find the ellipse of the bottom and top and the bottom edge. So we're going to find the ellipse of the top plane and the ellipse of the bottom plane using those division points. And then we'll draw the sides of the cylinder, which were already found when we found the center of the right and left planes. So there's your cylinder within your cube.